Welcome to today's American Security Project webinar. This is an on-the-record conversation that will be available for attribution. A recording of this conversation will be posted on our website. All audience members will be muted during the discussion, but please use the Q&A box at the bottom of your screen to ask any questions to the panelists. With that, I will turn it over to ASP Senior Fellow for Climate Security, Jessica Olcott-Yamo.
Good afternoon, and thank you for joining us today. I am Jessica Olcott-Yamo. I am the Senior Fellow for Climate Security here at the American Security Project, and I am pleased to welcome Mr. Stanley Darbro and Commander Michael Knickerbocker joining us today from various positions, but here today to talk about EVs in the military. Mr. Darbro is the Deputy Director of the Rapid Capabilities and Critical Technologies Office for the U.S. Army in Fort Belvoir, Virginia. He has a wide portfolio that includes the Rapid Acquisitions Prototyping Project Office, the Advanced Concepts and Experimentation Project Office, and the Computing and Electronic Security Dominance Project Office. Also joining us is Commander Michael Knickerbocker. He is a surface warfare officer for the U.S. Navy, currently assigned to the Clements Center as part of the U.S. Navy's Federal Executive Fellowship. Gentlemen, thank you for joining us today.
Glad to be here, Jessica.
Great. Mr. Darbro, the first question is going to be for you. I will weave in questions from the audience as they come in and as the time allows. Let's just start with the basics. Can you walk us through the differences between tactical and non-tactical vehicles and the challenges and missions that those elements face and how your office plays into that evolution?
Morning, Jessica. Thank you. And thank you for letting me be part of this today. Let me try and explain just a little bit about the hybrid electric and how we look at that from our office and from within the Army. If we look at how we solve it in the civilian world, non-military, then we're out trying to build the industry. Ford, Chevy, others are trying to build electric vehicles and hybrid electric vehicles. The Prius is a great example. So they're saving on fossil fuels, they're saving on gas, and you go a lot further before you have to fill up. That's the problem set there, was to be able to drive a vehicle without having to use so much gasoline or fossil fuels and run off of full electric. And that works out quite well. In the United States Army, we would like to be able to do both. We want to be able to run vehicles and other things such as forklifts and other stuff off of pure electric and not have to use fossil fuels to go do that. So that's one set, and we work that. Those would be, we would use those kind of vehicles for things that we don't ship over to a theater somewhere where we have to go into conflict with someone else or with another country. So we would use those for commercial vehicles that we use here in the United States and that sort of thing. The other part that we have to do in the Army is we need electric on those vehicles that will power organic capability within those platforms. So as an example, we might want to put out, and we're building a Bradley vehicle and a Stryker vehicle. And a Stryker vehicle, we want to put a laser on it, a 50 kilowatt laser, and the Army's actively doing that today. We may want to put a small radar on that particular platform or another platform. And when we put those organic capabilities on those vehicles, we need electricity to go do that. So our need for tactical vehicles is both save on fuel and reduce the fossil fuel usage. So use that gasoline as low as possible. And the way we do that is we use electric to go do it. But I need more electric, not just running the engine. I need electric to run that organic sensor or that organic weapon system, such as a laser, and to charge other things that our soldiers carry with them. And I need to be able to take some of that electricity and offboard it off that platform, perhaps to run some equipment that's in a tent or stationary or command and control or something like that. And I need electricity to go do those things. So while industry is selling full electric vehicles, they're solving one problem set in most cases. And then for the tactical vehicles, I have to solve two problems. One, the fossil fuel and use less fuel. and two, generate more electric in order to allow those organic uses of onboard sensors, if that makes sense.
It does. Thank you. Commander Knickerbocker, does the Navy, although I know that you're not speaking for the Navy, but in your expertise, does the Navy approach it similarly? How are you seeing the EV evolution throughout either tactical or onboard ships or on installations? What are you seeing on the ground in terms of electrification and EV revolutions?
Thank you, Jessica. So just clarify, I am here as a individual. My opinion is not reflected at the University of Texas or the Navy. I'm not currently involved in any program specifically with the Navy. Where I have gone from is as an operator advocating for where I see potential opportunity. And largely to what Mr. Darbro said is, the Navy's looking at its fleet vehicles that are United States side or at bases instead of forward operating areas. So I kind of see that as like the stepping point of adopting electrical vehicles to reduce the fuel usage of our fleet. Now, where I also see is, again, as Mr. Darbro said, looking at forklifts, tow tractors, and support vehicles, both from a continental US side, but then where my writings have kind of tried to advocate for as the Navy puts out its plan and starts adopting technology, is also looking for the adoption of those type of platforms on board aircraft carriers or with small boats on board smaller ships. So the 7-meter small boat that we use on board destroyers, frigates, and cruisers.
Very interesting. So we've just had something pop into the chat here, and I'm going to go ahead and toss that out for either of you to take. Do you foresee the Army or the Navy or big DoD setting up charging stations in the operational environment?
So if I can, let me jump on that and turn it over to Commander Knickerbocker. I'm going to go back just a little bit what I was talking about earlier to help answer that question. Do we see charging systems in operations? One of our problems in the Army, being very, very tactical, we don't stay in the same piece of land for very long. We're always moving forward, right? So when you go from one field position, as I'll call it, to another field position or tactical area that we're going to, our problem is we can't.
Oh, I think he may have froze. Uh-oh. I think we may have lost Mr. Darbro.
The new, we can't charge cost too much. So for us to charge, are we okay? Am I back now?
Yeah, I think you're back now.
There we go. Do you have? Okay. So our Army is the U.S. Army. So the electrical vehicles have to keep charging. So that's why we do a hybrid electric instead of full electric. We can't charge on the move. The only way we can charge on the generator to charge us on the move, so that's why I can't do it. So for us, we can't charge on the move. That's why most of our tactical vehicles would be more of a challenge for us to go full electric for those reasons. So in locations that we go in operational locations, if we're going to be stationary for a long time, could we charge things at that location? If we're going to dig in for a while and we have established for a long-term period, maybe for vehicles that are not tactical, you have to be able to keep moving. Once you've used the electric that is on your vehicle, it has to recharge. So in our case, some cases we'll be using batteries to do that. So something has to recharge that. And we usually use that.
Mr. Darbro, I think you're breaking up a little bit here. Commander Knickerbocker, do you have anything to add about that distinction?
So this is where I think the Navy has a significant amount of opportunity. If you look at things like small boats, ground support equipment on carriers, or even operating UAVs, UUVs, and USVs, unmanned vehicles in the future, is we have excess generator capacity, whether it be through nuclear power on a carrier, or looking at the gas turbine generators, or even diesel electric generators on our other classes of surface ships. So we kind of are our own mobile microgrid, for lack of a better term. And I think, as Mr. Darbro was alluding to, as technology continues to come along, and we see these goals of establishing microgrids and not being reliant on domestic energy sources overseas, we may then be able to broaden the scopes of what we're doing from what many would know as electric vehicles, or plug-in hybrid electrics, or the hybrid vehicles that we see that many know, talking series versus parallel hybrid drive systems. And so where I think in the future, though, is, I've seen the attack of, oh, well, you don't have charging stations in downtown Baghdad when we were doing Iraq. Well, we're also not pulling up to a gas station in central Baghdad during a fight. So I kind of feel that those counterpoints tend to be lazy. And I think that, one, as battery technology continues to advance, and we're seeing that every day, and we're, potentially solid state batteries on the horizon, we're looking at things that are going to make it more portable for excess backup power to then be able to look at bringing that. There's a company called ChargePoint that now has essentially what is an electric jerry can, and able to take charge to a vehicle, and we'll continue to see the capacity and charging rates of those improve. So maybe down the road at one point, but a lot of that base technology is there, and it's just getting to a state of maturity and reliability where it can be used in more of a tactical role. But I do feel that the Navy, given that ships are their own sources of power for operating our systems, we can take a lot of unmanned systems, or even manned support systems, and be able to do operating and testing with them to get them ready to go overseas, operating out of forward operating base or other operating environment.
Mr. Darbro, are you back up technically?
So there we go. Can you hear me okay now, Jessica?
Yes.
Super. Oh yeah, I agree with Captain Knickerbocker. That is trying to enhance battery technology to make batteries last longer, put out more capability, more amperage, more volts, that kind of thing. We are personally working on that in my organization with industry for much smaller scale items that we're working with industry on. But we have others within the department that are working the bigger batteries. And I think what we're looking at now is probably out in the 2035 time frame, maybe a little sooner, a little later. We think the battery technology will keep maturing as they look at different ways to do that chemistry to make the electricity flow and last longer in the batteries. 2035, we'll do a lot of hybrid electric where we turn it off for a while. We run on. We'll be able to run our tanks hours more as we get closer to the enemy, and that's very important to us. And so we won't necessarily hear us coming. We do things that are called silent watch, where we just run those things. We're not driving the tank or the vehicle, but we're watching and we're observing what's out in front, what the enemy is doing, and we can do that with our electricity that we have stored on. As we learn more about the chemistry and make those changes, and the batteries last longer, that now give us opportunity to take tactical vehicles to full electric. But I think we're a few years away. I think it's probably somewhere around 2035 as we talk to industry.
I did see yesterday, the Department of Navy released its Climate Action 2030 plan. And there's actually a specific call out for the Department of Army and the Department of the Navy's collaboration on lithium ion batteries for tactical ground vehicles. So if anyone in the audience hasn't looked at that, it's very interesting stuff. So along those same lines, when we're talking about supporting the warfighter and making sure that we can ensure mission effectiveness, any evolution has to ensure that we safeguard our soldiers as much as possible and we're able to achieve the mission. So thinking about this conversation and EVs and tactical vehicles in a combat situation, if we pivot and look a bit about what's happening in Ukraine and Ukrainians' ability to attack and pick up the logistics from Russian tanks that have run out of fuel, do EVs have the capability to mitigate that problem, or is it just trading one problem set for the other? Or if we employ EVs in a combat situation or in a precarious situation, is that going to be safe? I mean, surely we wouldn't put anything in the field that wasn't ready to go, but what are your thoughts on that evolution? How we would be moving away from fuel and back to electrification?
So I'll jump on that real quick. I think there's some great points that you brought up, especially on the safety, right? So one of the things as we go to hybrid electric vehicles and then eventually full electric vehicles is you now have a lot of electricity that's on a vehicle that was never there before. So our mechanics and our operators are used to going in and they know what not to touch a negative and a positive post at the same time on a battery. That'll be a bad outcome. So we know that. So, but with all this electric on there, we now have to be able to train our soldiers and likewise airmen and sailors and so forth on the hazards of the electricity, right? So now if we have a hybrid electric or a full electric vehicle, what are the areas that they need to be cautious of and where not to touch it? So even in today's commercial environment, when an electric vehicle gets into a car accident, that's one of the things now tow truck drivers and others have to worry about. What not to touch? Is something still putting all that voltage out? So that's a training process that we have to do as well. Is it insurmountable? I don't think so at all. I think it's a matter of as we go into new technologies and use it in different ways, is a learning factor, a learning curve where people have to learn what they can and they can't do and where those hazards are. So when we go back and we look at like in Ukraine, if the Russians run out of fuel in their tanks, they've been in a position where our supply lines can't get cut off. We can't go forward. By going to a hybrid electric vehicle and then ultimately an electric vehicle, that problem goes away. So if the grid goes down and we can't charge something because we have to use their local electricity, that could be problematic, right? So we'll always want to make sure on our tactical vehicles, we have our own organic way to be in our thought process of how do we charge that or recharge that full electric or hybrid electric. So there's some challenges out there. I think we're aware of what those challenges are, and we got some great people working on that.
Great. Commander Nickelbacker, anything to add?
The only thing I would add without specifically discussing the current war in Ukraine is boiling it down to contested logistics, whether it's trying to continue to move forward and gain territory from a land warfare perspective, or resupplying ships at sea. Where I really see electrification and hybrid electrification being of benefit to the military is just being able to stretch what we have available to us further for those current operations. For every piece of equipment on a carrier, if I'm not using fuel for my tow tractors, that's more fuel for aircraft. if I'm using, if I'm getting more fuel efficiency out of the vehicle, that's fewer convoys I need to lead in. And I think that that's where the real discussion is it becomes about economy of resources so much instead of just about whether we're using electric or fossil fuel. It's just getting systems that are more efficient at using that limited fossil fuel in theater, and also at being able to then use the man hours to operate and maintain those vehicles in combat and non-combat situations.
Great, thank you. So let me ask, where are we? Where are we in terms of deploying some of this technology and using this? Are you hopeful for particular milestones that we'll achieve? Are there new evolutions on EVs or electrification in the military that you're particularly excited about?
So that's another great question. Thanks, Jessica. So today, what we're doing in my organization is we're working on 3 different types of vehicles for hybrid electrification. And I'm going to call those vehicles surrogates. And the reason it's a surrogate is if we can prove it out on certain what we have learned from that technology to the entire fleet of vehicles or similar vehicles. So today, the Rapid Capability Critical Technology Office, one of my commanders that works for me, is developing a hybrid electric Bradley.
Oh, I think you broke up right there. Hybrid electric
vehicle. We're building 2 prototypes today. We've already, Bradley, can you hear me now? Broken up again? Let's try it again.
Okay, I lost you, I think at hydroelectric.
Okay. Okay, do you have me back now?
A little
you
bit.
Hear me okay now, Jessica? Okay.
Yeah, I think
so. So we're building 2 Bradley hybrid electric vehicles as prototypes. We've already had engine start on those vehicles. So we already know it works, right? So now we have to take it out later this year towards the fall, and we'll do some testing with it at the ranges. And we will test those Bradley hybrid electric vehicles against other Bradley vehicles that are non-electric. And we'll see the difference in the value to do some of those other missions that I talked about earlier. So we've started that process. It is a 24-month effort to do 2 prototype Bradleys, hybrid electric, and we are about 22 months into that. So another couple months, we'll be done putting them together and we'll be in some testing phase. And so far, all of our expectations on performance has worked out fine. So we think that's going to work out good. There were some challenges. The Bradley's the smallest track vehicle. So if it works in that, it would be easier for us to integrate those kinds of technologies into others like the AMP-V or Abrams or other vehicles, as those chassis are bigger and easier to integrate with. The other thing we have just started recently, Jessica, is we started another effort to take the Army's Humvee, which is a massive fleet of Humvees that are out there, been out there for a long time. They're going to continue being out there in the Army for many years to come. So we have started that effort about a month ago, and we put on contract for 2 different companies to build hybrid electric Humvees. And so we're 2 months into it. It is promising. We don't foresee any problems right now that are prevent us from being successful on that. And then we have another effort that we started with the Joint Tactical Light Vehicle, what we call the JLTV. We're doing a hybrid electric on that. So Secretary of the Army gave us those directed efforts to go out and build hybrid electric for those 3 types of vehicles. And based on the outcome, the Army goes permanently to make changes to our entire fleet out there. So those are the 3 we're doing. The JLTV and Humvee, we just started. They're both on contract with vendors, and they're actively pursuing those. And let me say one more thing. Let's think about the fuel savings for a second and going green. If I can save 20%, even if I can save 10% on fuel, someone might think, well, 10% probably not very much for the vehicle, or 20% is not much. If I look at that and I apply that savings across the entire fleet of those vehicles, and I have 10% or 20% for each of the vehicles in the fleet, that's a significant savings of fossil fuel. That's a significant amount less of fuel trucks, pods that I have to send out there to the field with the soldiers to keep refueling them. And that's a significantly less amount of opportunity for the enemy to kill some of our soldiers because we have them out there driving around in fuel trucks. And that makes a big difference. And it saves lives and it reduces the use of fossil fuels as well. So that's very exciting to us. And so far, those 3 programs appear to be working fine.
That's great. And this is a toss-up question for either of you, but Commander Knickerbocker, maybe you could talk a little bit more from an operator perspective. What do you see are the most important investments that need to be made to move this along, and sort of the inverse of that, which are what are the biggest constraints that you're facing right now?
So again, with just echoing everything that Mr. Darbro said, where and what I love that the Army's doing is looking at their smallest track vehicle, the Bradley, as then they start to do spiral development to larger platforms. And I think that's where our investment needs to start, is going at that lowest level, getting the technology right there, and then spiral development to the next level and continuing to grow that technology. Because unfortunately, we have seen with American industry, and especially with the Navy, you look at some of our shipbuilding programs, sometimes we're the victim of looking for that technological silver bullet and trying to do everything all at once in our first attempt at new technology or a different adaptation of existing technology. And I think that's where we need to start our investments, is going for those lower risks, more controlled environments, and then continuing to grow it from there. Because if we do feel that, in the long-term future, hybridization and electrification is going to be needed for combat, hopefully we're many, many years away. But as history has taught us, necessity and urgency can often be the drivers to a quicker breaking through of barriers. So in the event that things get pushed, perhaps we can expedite that development timeline.
Mr. Darbro, any thoughts on that?
Yeah, I think I agree with everything that Captain Knickerbocker just said. Here's I'm encouraging industry daily as we work with them to go out and work on the battery technology and the chemistry, as I was saying earlier. It's very, very important for us for the batteries to last longer and take less effort to recharge them. And that's going to make a big difference for us. But batteries isn't the only place that electric comes from, right? There are companies out there are building things, and we consider them they have different names for them. You consider like a capacitor, if you will. Oh, that's not what they're calling them. And they take these components and they charge electric in them, and it holds that electric until you need to discharge it. And then you slowly use that electric, and then you have to recharge that again. Similar to a battery, but it's a different component that would go do that. So we are encouraging industry to keep working with us to find more ways to generate the electric and then store that electric. And so we can use it. So I think that's going to keep going. One of the other things that happens to us is I get people ask me all the time, says, well, why can't you add something onto the vehicle if you don't want to pull another trailer, which we can't do that, defeats part of our purpose. Why can't you just add something to the vehicle that makes it charge the batteries more often? Things like its own generator setting on the vehicle. Remember, every vehicle that we have that is tactical, we're concerned about how much weight goes on that vehicle. A lot of our vehicles are armored. That takes up a lot of weight and uses a lot of fuel and uses a lot of energy. And if you look at our tactical vehicles today, we not only carry other soldier things on there and weapons and peripherals that we need in order to accomplish the mission, but there's not much room in that engine compartment. So one, adding weight is a problem, and two, the real estate is a problem. So where might we put something onto a vehicle? It wouldn't be anything small. It'd probably be something that's a pretty good size, and places to put that on that vehicle is problematic or challenging as well. So so it's not anything we really take off at this point. The technology is not there, so we just keep adding things. So that location, that real estate on a vehicle is problematic. But I think as we look at technologies and more advance them, I think the industry is just as concerned as we are. One of the good things is every car manufacturer, how to get full electric, and then how to make it last longer. So they're looking at batteries just like we are, for a different reason, because remember, they're only solving one problem set, whereas we're solving two. So we're very excited about the technologies that the industry is working.
Wonderful. Who do you consider some other, other industries, right? So battery manufacturers or critical mineral companies. Who do you consider to be the key partners that the Army or the Navy or the military writ large needs to be working with domestically or internationally to get this moving quicker?
That's a good question. I'll answer that and turn it over to Mayor Knickerbocker. I'm working with several different places. We tend to think of industry as the ones that you see on TV, right? Ford, GM, Chevy, G, those kinds of things. But there's much more out there. We're working some battery technologists, some of the universities. So Michigan Technical University, we're working with them. There's a company in California named Banks, and Banks builds engines. I was just out at their manufacturing plant a week ago. Sat down with the team out there. They're doing a great job, and they're looking at hybrid electric as well. So, and how might they run those engines also using electric? So they're working on some of that technology to help us get to where we need to go on hybrid electric. And Oshkosh, as you know, not only does military vehicles, but they build a lot of the fire trucks and fire engines and other apparatus for our first responders that are out there. And how they use that electric and how long they can get those batteries to last is of great interest to them as well. So we have your normal known manufacturers out there working towards it. We have universities that are out there with some really bright students and great opportunities to look at the chemistry and how we're doing, and we have them employed working it. And then we have the ones that are not so obvious, but smaller companies out there that are also helping us look at those kinds of technologies. And I'll pause there for the commander.
So not being directly involved in any programs, but what I did find in my research is, again, what Mr. Darbro alluded to is, one, we have an extremely large capacity in the United States in the academic environment, and what technologies and research are happening there across the country. But also, looking at small companies that nowadays, instead of trying to be more general, you see a lot more American companies, especially small businesses, where they're looking at niche problems. If you look at some of the companies that are trying to address things like maritime transport with sea gliders or ground effect vehicles and what those propulsion systems are, and then looking at trying to get battery, like a lot of these companies are bringing in these great minds and trying to solve one part of a problem set instead of trying to solve the entire problem set. And I think that level of focus is going to yield some fruits for American technology and industry moving forward.
That's wonderful, and a very hopeful note to get ready to wind down here. Unfortunately, we are just about out of time, but we've got time for one or two more questions. So I'll take one from the chat here. How much have you seen DoD adopt non-tactical electronic or EV vehicles in their fleets so far?
That's a good question. I'm not sure we have a lot of tactical hybrid electric out there yet. That's what we're just now starting to about the hybrid electric Bradley as an example. That's being done by BAE up in Michigan. So so we're not doing that so much now. A lot of industry is. So you have the electric buses now. You go to a lot of big cities and your whole bus will be electric. We are, and that's helping. And some of those components, as a matter of fact, we are adopting and using to help us get the tactical vehicles. So if I look back to Bradley, we probably have about, I don't know, 16, 18 different components that are separate on that vehicle that allow it to become a hybrid electric vehicle. Of those 16 to 18 different components, all but 2 of those exist today. We're just buying those commercial off the shelf. We're integrating those onto our tactical vehicles. So a lot of your technology exists today. Some of the technology that doesn't exist for us is what we call the hybrid electric drive. And that hybrid electric drive transfer that electricity from the engine over to run our transfer cases and then make the wheels turn and the tracks turn. And depending on how much tonnage or how much weight you have on those vehicles, drives on how that electric kind of torque it needs to handle, and that brake or doesn't. So we don't have any tactical vehicles deployed today, but those are the ones that we're working on now to go do that. Does that help answer some of your questions, Jessica?
Sure. Commander Knickerbocker, did you want to chime in?
So I personally haven't seen a lot yet in like the non-tactical government vehicle fleet. I mean, definitely you've seen more command vehicles that are Priuses, and I'm sure as we move forward, we'll continue to see more adopted and placed into service. But again, it's just a matter of I haven't been anywhere where I've seen it and not directly involved in acquisitions to know what that acquisition distribution plan would look like.
Okay, that's fair. So my last question before we wrap up, and then I'll ask for any final comments from both of you. The Navy strategy in particular calls for acquiring 100% zero emissions vehicles by 2035. Doable?
I definitely think it's doable for my own personal opinion. It just, again, comes down to what is the actual meaning behind that statement? What vehicles are we discussing? If we're looking at like our government vehicle fleet, then absolutely doable. But as we start to look at some of those things, such as the buses we use, heavy lift trucks and the like, then it's just a matter of, you know, budgetary constraints, appropriations, and then where is the technology to meet those needs to the right levels. So is it doable? In my opinion, absolutely. It's just, again, breaking down that statement to understand, okay, what does that goal actually entail as to whether or not we'll get there.
Mr. Darbro, do you have any thoughts on wider DoDs? I know that was the Navy strategy I was talking to specifically there, but do you have any thoughts on achieving the DoD's big goals for EVs?
Well, so by 2035, I am very, very hopeful, and I'm pretty confident that yes, we're going to get there. Are we going to get there by goal? I think the possibility to do that is certainly exists. So, but you just have to remember, we can't take the batteries and make them better overnight. This takes scientific work, right? You have to have certain materials along with certain fluids and chemistry to make that action happen, right? So in our batteries today, everybody knows we use electrolyte. So is there a different kind of electrolyte we can use? Can we change the way that's made? And the materials that it works with, we have to find those materials. That's some really hard science work, and we get progress that they have made so far in making changes to the battery besides the batteries. as we look back in the progress we have made, and then we can project out in the future, how much longer do we think it would take in order to prove out new technologies, many of which we're already working on. I think that 2035 is a good timeline. I think it's doable. I think we can do it. We have to apply resources to that. It's not free. And as our money gets diverted for other efforts that happen in real world problems, that may slow us down a little bit. And but I think the money and the technology, I think, is there. It just takes a little bit of time to get it done. So yeah, I think it's doable.
Well, that is wonderful to hear, and ending on a positive note is something I always try to do. So, and I think both of the points that you've made, all of the points that you've made here have been extremely enlightening. And it's very important to remember for our audience that this is not going to happen quickly. We are not going to employ anything that hasn't been rigorously tested. At the end of the day, we want to support the warfighter. We want to make sure it's a safe investment and safe to execute in the field. So it will take time, but there is hope, and there is definitely progress already underway. So gentlemen, thank you so much for joining us today. Everyone in the chat and online, thank you for joining us. I apologize for not being able to get to all of the questions, but I sincerely hope that we're able to have you back and you can join us again and talk to us about all of the exciting developments in the EV and military world.
Thank you, Jessica. Happy to be here.
Happy to participate. Thank you very much for the invitation.